This chapter explores metals and nonmetals. It explains how these elements are classified and what makes each group unique. You'll learn about their physical and chemical properties. For example, why metals conduct electricity and why some elements are malleable while others are brittle. The chapter also covers how to extract these elements from their ores, including smelting and refining. It shows how properties connect to real-world applications, like iron in construction and copper in electrical systems. Nonmetals like sulfur and chlorine are used in manufacturing and water treatment. Understanding an element's nature and its uses helps you recognize why certain materials are used in everyday objects and industrial processes. Metals have several distinctive physical properties. They have a natural shine and are often hard. However, some metals like sodium and potassium are soft. Metals can be beaten into thin sheets and stretched into wires. They conduct heat and electricity, with silver and copper being the best heat conductors. When struck, metals produce ringing sounds. Nonmetals are usually solids or gases and are poor at conducting heat and electricity. They are not malleable or ductile and lack luster, except for iodine. There are exceptions like graphite, a form of carbon that conducts electricity, showing that elements can have different properties. Metals have important chemical properties. Most metals react with oxygen to form metal oxides. Some, like potassium and sodium, react vigorously and can catch fire in air. They are stored in kerosene. Aluminium oxide and zinc oxide react with both acids and bases, producing a salt and water. Other metal oxides, like sodium oxide, dissolve in water to form alkalis. Metals react differently with water depending on their reactivity. Some, like potassium and sodium, react violently with cold water. Others, like magnesium, need hot water to react. Lead, copper, silver, and gold do not react with water. Metals also react with acids, producing a salt and hydrogen gas, except with nitric acid. The reactivity series ranks metals from most reactive to least reactive, helping predict which metals can displace others. The octet rule explains how atoms interact. Atoms aim for 8 electrons in their outer shell. Noble gases have full shells, so they're not reactive. When ionic bonds form, metals lose electrons and become positive, while nonmetals gain electrons and become negative. These oppositely charged ions stick together. Ionic compounds are solid and hard due to strong attraction between ions. They have high melting and boiling points. Examples include sodium chloride, lithium chloride, and calcium chloride. These compounds dissolve in water, but not in organic solvents. They only conduct electricity when dissolved in water or melted, not in solid form. A mineral is a naturally occurring element or compound in the Earth's crust. If it contains enough metal to be extracted profitably, it's called an ore. Ores have unwanted materials like soil and sand, known as gangue, which must be removed. This process is called enrichment of ores. Extraction methods depend on the metal's position in the reactivity series. Metals can be extracted through heating, reduction, or electrolysis. The method used depends on the metal's reactivity. After extraction, metals often need refining to remove impurities. Electrolytic refining is a common method used to purify metals. Corrosion is a natural process where metals deteriorate. Silver turns black, copper turns green, and iron produces brown rust. Rust is iron oxide with water molecules. For iron to rust, it needs moisture and oxygen. Iron doesn't rust in boiled water or dry air. To prevent corrosion, methods include painting, oiling, and greasing. Galvanization coats metal with zinc, which protects the metal if damaged. Chrome plating and anodizing also prevent corrosion. Alloying combines metals with other elements to make them more resistant. An alloy is a mixture of 2 or more metals, or a metal and a nonmetal. It's made by melting the primary metal, adding other elements, and cooling it. Brass is an alloy of copper and zinc, used for decorative items and musical instruments. Bronze is copper and tin, used for coins, statues, and bells. Solder is lead and tin, used for welding electrical wires. Stainless steel is iron, nickel, and chromium, used in kitchenware and medical equipment. Gold alloys are also used, with 24-karat being pure gold and 22-karat being gold mixed with copper or silver for jewelry. Alloys have lower electrical conductivity and melting points, but offer improved hardness and durability. Nonmetals have three main types of chemical behavior. They react with oxygen to form acidic or neutral oxides, such as SO2, CO2, and NO2. These oxides produce acids when dissolved in water. For example, SO2 reacts with water to form sulfurous acid. Nonmetals also react with hydrogen to create hydrides, but they don't displace hydrogen from dilute acids. Additionally, nonmetals gain electrons to form negatively charged ions, like chloride, oxide, and sulfide ions. These ions are written as Cl2 and S2. Nonmetals form acidic oxides combine with hydrogen to make hydrides and gain electrons to become negatively charged ions. Metals have a shiny appearance called metallic luster. They can be hammered into thin sheets, which is called malleability, or pulled into thin wires, known as ductility. When struck, metals produce a ringing sound, making them sonorous. Metal oxides can be special, with some reacting with both acids and bases. The activity series ranks metals by their reactivity. Metals and nonmetals can form ionic compounds by transferring electrons. Ores are minerals that can be extracted for metals, but they contain unwanted impurities called gangue. Corrosion occurs when metals react with their environment. To prevent this, iron and steel can be coated with zinc through galvanization. Alloys are mixtures of metals or metals with nonmetals. Some mixtures, like aqua regia, can dissolve gold. The Thermit reaction involves aluminium reacting with metal oxides, releasing a lot of heat. Metals are extracted in different ways based on their reactivity. The most reactive metals, such as potassium and sodium, require electrolytic reduction. Moderately reactive metals, including zinc and iron, are extracted through reduction with carbon. The least reactive metals, like silver and gold, are found naturally and need minimal processing. Metals have unique properties that make them useful. Malleability allows them to be shaped into various forms. Ductility enables them to be drawn into wires. Thermal conductivity makes them suitable for heat exchangers. Sonority means they can produce sound, making them useful for musical instruments. Resistance to corrosion helps them maintain their appearance, ideal for jewelry and decorative items. Metals and nonmetals are classified based on their physical and chemical properties. This classification helps predict how materials behave in different situations. The reactivity series shows how metals react in chemical reactions and which methods work best for extracting metals from ores. Ionic bonding explains how atoms form compounds. Corrosion is the breakdown of metals when they react with their environment. Alloy formation is the process of mixing metals to create stronger materials. These concepts are important because they apply to real-world uses, from everyday items to industrial processes. They provide a foundation for understanding material science and how chemistry shapes the materials around us.